Thank you, Ms. Ranjita. So it's my privilege again to introduce our resource person for the first session. Dr. Hasan Firdaus bin Muhammad Zaki is a respected senior lecturer, researcher, and leader in the field of engineering and technology. He serves as the director of the Center for Unmanned Technologies, CUTE, at IIUM, Malaysia, and coordinates the Embedded AI Lab within the center. With a PhD in computer science from the University of Western Australia, a Master of Engineering in Mechatronics from the University of Malaya, and a Bachelor of Engineering Honors in Mechatronics from IIUM, Dr. Hassan's academic achievements reflects his dedication to excellence. He is recognized for his expertise in deep learning, robotics, and unmanned technologies. He has made impactful contribution through research on AI-driven solutions for diverse sectors, including automotive, medical robotics, healthcare at the edge, and traffic management. As a leader in government and industry-sponsored projects, he drives innovation by designing and developing cutting-edge AI technologies that address real-world challenges. In his role as director of CUTE, Dr. Hassan oversees transformative research initiatives such as autonomous surface vessels, advanced driver assistance systems, and vision-based automated manufacturing defect detection. He has published extensively in reputable journals and flagship conferences and is a trusted advisor to public and private agencies, contributing his expertise to critical projects and policy making. His professional affiliations include memberships in the Board of Engineers Malaysia, the Institution of Engineering and Technology, and Lembaga Technologies Malaysia. Okay. With this, I would like to welcome Dr. Hasan. Welcome you, sir.
Okay, thank you, Mr. Chairperson and Mrs. Chairperson. Can you hear me? Am I audible?
Yes, sir.
All right, thank you. Before I start, let me share my screen, shall I? Okay, so this is my, okay. All right, good evening, everyone. So how are you guys doing? So hopefully you are all in a good health condition. All right, so let me firstly address the guests of honors, the faculty members, the head of departments, academics, staff members, students, and all participants of the program of faculty development program on deep learning, intelligent video analytics, and computer vision. All right, so I am Hasan Firdaus bin Muhammad Zaki. So I'm currently an associate professor at the International Islamic University Malaysia, IIUM. All right, so I'll be delivering a talk. The first session of this 6-day program on the introduction to deep learning. All right. All right. So our sessions beginning today and onwards will be some sort of the mixture of between the theoretical and more towards the hands-on part. Okay. So I will detail out on our agenda afterwards. Okay, so before that, let me introduce myself first. Okay, so I'm currently also the director of our center. So our center is called Center for Unmanned Technologies. So or the term is CUTE, CUTE, CUTE. So Center for Unmanned Technologies. So this is under the School of Engineering in IUM. So I graduated in computer science, PhD in University of Western Australia in this area. So the area of computer vision and deep learning. Okay, so I'm also the principal investigator for various projects with the ministry and industry in Malaysia. Okay, so for example, here I'm involved with several projects with industries in automotive, for example. Okay, and for the oil and gas and others. Okay, so I will detail out after this. I will share. All right, so our center have several labs. Okay, so I'm belong to the embedded AI labs. So in our center, we also have several other labs. So for example, we have maritime robotics lab, aerial robotics lab, doing drones, mixed reality, okay, robot design, and others as well. All right, so yeah, before we start with the topic of the deep learning, I would like to introduce to my center a little bit. Okay, so at Qt, okay, for our center, normally we are targeting technology readiness level of a higher level. So if you are familiar with the TRL level, technology readiness level in the prototyping of or the product. So normally we are targeting the technology readiness level from the 5 up to the commercial parts. Okay. Right. So we are also very active in involving with the projects with the government. So, for example, now we are active in collaborating with the Ministry of Home Affairs in Malaysia to develop a national border control system. All right. We are also active in giving a competence training. So, for example, now we are delivering a training on ADAS, so Advanced Driver Assistance System. All right. So at the same time, we are also conducting the internships. Okay. So recently we received the internship students from India as well. All right. So from Lord's Institute, just I think 3 weeks ago. All right. So we are also active in collaborations with the industry. So, for example, we are developing robotic solutions and AI solutions with the oil and gas company, Altus, and Deloitte. So Deloitte is an automotive company. All right. At the same time, we also have our outreach wing. So we are also active in delivering the robotics and AI workshops to the underprivileged participants. Okay, in Malaysia. Okay, and we are also delivering the professional certificates in this regard. Okay, so these are the contents of my session. Okay, so I will start by introducing on the AI. Okay, and then we discuss a little bit, why is AI taking off now? All right, so instead, because if we see AI is, based on all techniques or all algorithms. So, but why it taking off recently? Okay, all right, and then we'll talk a little bit on what we are doing in UM. Okay, AI at for unmanned technologies. Okay, and we'll discuss on what we should expect from these sessions and the upcoming sessions as well in our 6-day program. Right, before we start, can we have this activity first? Okay, can everyone go to this QR? Because before we start, we want to actually survey. We want to actually survey on the background of our participants, because we I'm understood that our participants are some 200 participants from across the country in India. So we like to know, like basic the demography of the participants. Okay, so that we can cater to the needs of the participants in the upcoming sessions. All right, so can everyone go to this link? And or easy, if you want to use the handphone, you can directly scan this QR code. Okay, let me know if you have any problem going into that. Okay, let's give some 20 seconds
Excuse
for.
me, sir. Could you please share the link in the chat box?
Oh yeah, sure. All right, so let me share this link in the chat box, okay, so that everyone can be open. All right, so the chat box is here. Okay, so all right. Okay, so this link will use a Mentimeter. All right, so just a simple activity that we want to start before we actually go into our topic. All right, let me open the. Okay, I think this one. Okay, you should get something like this. Okay, join at menti.com. So you can just use your handphone. All right, for easy access. Let me know if you have any problem. Right, so let's see. Okay, so this is just a simple activity. Just want to see some demography or the background of our participants. So what do you already know about deep learning and computer vision? So just out of curiosity. So how do I start this? Okay, so no, go to next slide. Okay, all right. So from 1 to 5, how well would you say you know this topic? Okay, uh, I'm afraid this Mentimeter could only allow some, because this is a free version. I just made it quickly just now, so I think it will only allow some 50 participants. So don't worry if you cannot access it after the quota have been fulfilled. Don't worry, I just want to see the at least to get the majority of the participants. Okay, so looks like we have I think 49 responses. Okay, good enough. Oh, now it's already 50. So I think this. Oh, actually, we can get more than 50. Okay, so from this first question, okay, how well you say you know this topic? Okay, so some 6 of the participants say not at all. So meaning probably never heard about deep learning or AI or computer vision, right? Okay, so looks like the majority. It's a very nice normal curve. Okay, uh, uh, where we have the majority at the 2 and 3. No, meaning the majority knows a little bit. Okay, knows a little bit about deep learning. Okay, similar amount of people say they know a fair amount of deep learning. Probably they have gone to the classes of introduction. Okay, probably took some courses in their university, right? Okay, but yeah, looks like the vast majority is at the a little bit. Okay, probably no at the surface. No, a lot. So we have some probably some practitioner of deep learning and computer vision here. Okay, 5. All right. Okay, so this is a very good to know. So looks like the majority of our participants is actually at the center of the normal distribution. Okay, so therefore probably this session and the next we will be catering more towards this demography. But of course, our sessions are also designed to cater also from the beginner, the intermediate, and close to the advanced level. Okay, hopefully. All right. Okay, good. So let's go to the next question. Have you studied this topic before? Wow. So looks like we have a balance yes and no responses. All right. So we have 30 response yes. Okay. But 28, which is similar to the yes. So no at all. So meaning yep. So we will therefore probably we will cater this demography in the next session. Okay. Don't worry at all. Okay. Because we are here to cater to your needs. Okay, all right. So what comes to your mind when you hear deep learning? All right, so we have some 87 responses. Okay, we have some word cloud here. Looks like we don't have the, like uh, normally we will get the biggest word in this cloud denoting the highest voting, but it looks like the highest one probably in the AI, right? Artificial intelligence, CNN, okay, neural network, machine learning, okay, good. Probably less of the unstructured data, right? Okay, transfer learning and so on. Okay, good. Okay, all right. So at least we know that you already have some idea about deep learning. All right, so let's go to the next slide. Okay. Okay, so next question is which of these are key elements of deep learning? All right, so this question actually just want to know whether you are aware of the background or the foundation of deep learning. All right, okay. From this we can see that some 52 responses say that okay, neural networks is the of course the key element of deep learning, which is correct. Okay. It is at the core or the heart of deep learning. All right, you are correct. But that's not all. All right, so let's see other answers. So the answer is IoT, Internet of Things, gradient descent, blockchain, and cybersecurity. All right, so 5 of the participant response as gradient descent. All right, so actually gradient descent is also a key element in deep learning as well. All right, especially to train a deep neural network, we need a technique to update our parameters or our weight. So one of the methods that is popularly used, okay, or commonly used is gradient descent. All right, okay, no worries. So most probably because our workshop is more towards the hands-on part. Okay, therefore we won't go into the details of the fundamental. All right, but of course we will cover, but not in detail. All right. Okay, so just want to let you know that. Okay. All right, so that's it for our pre-course knowledge assessment. So now I am more clear about the demography of our participants, which is good to know. All right, so this our sessions as well. All right, for this 6 day is we hope that the sessions is more interactive. Okay, more interactive, meaning that we don't want it to be a one-way talk or one-way lecture. So that's some sort of lecture, right? So our program is more towards the workshop things. Okay, so if you have any problem, although while I'm presenting or other speakers are presenting, we hope that we can open the floor. Okay, and you can ask you can ask if you have any doubts or you have any questions. Okay, so probably you can ask through the chat box, okay? Or probably if you want to ask directly with your microphone, I think also can, okay? Also can. All right. Okay, so I hope that is clear. All right. Okay, so now let's move on to our topic. Okay. But just want to let you know, because I'm presenting in PowerPoint, so probably I won't see these Teams layout. So please let me know if you have any question in the chat box and others. All right, or you have any questions. All right. Okay. All right. So let's start our topic. Okay. Let me start our introduction to AI or deep learning with this quotation. All right. So this quote is from one of the people call him the godfather of AI. So one of them is Jan LeCun. Okay. So he's now is the head of Facebook Meta AI research. Okay. So what did he say? Okay, so one of his posts, he said, okay, I always have this question from my students, right? Okay, I'm not good at mathematics. Okay, can I really go or start my journey in AI? What should we tell? All right, so I always answer with this quote from Jan LeCun. So he says that in the history of science and technology, the engineering artifact often come first. Okay, for example, the telescope, the steam engine, digital communication, for example. So the theory that explains its function, okay, and its limitations often appears later. All right. So for example, the loss of refraction, okay, for the telescope, for example, and the loss of thermodynamics for the steam engine, and information theory for the digital communication often comes later. All right. So always in when new technology comes in our life, to the world, to the real world, we often use it as the applied things first. Okay, we apply and we use that technology first, although without really knowing what's behind the scene, or what's in the underlying of the artifacts or the technology. Okay, so with the emergence of deep learning, AI powered engineering wonders have entered our life, but our theoretical understanding of the power and limits of deep learning is still partial. Yeah, this is correct. This is correct, because even we as researchers in deep learning and AI, we some things, some phenomena we cannot fully explain yet. Okay, for example, why this model is very powerful in capturing some patterns. Okay, what are the really the mathematics behind it. Okay, but without fully understanding that doesn't stop us from use it to our advantage. Right. Okay, so if you are not a math geek, can you go to AI? Definitely yes. Okay, definitely yes. How? We'll see in our 6-day workshop. Hopefully this workshop can be the starting point, or the stepping stone for you to start in your adventure in AI, hopefully. Yeah. All right. So in this world of generative AI nowadays, Dr. Hazrat just now talked about ChatGPT and Gemini and other generative models. Okay, so because the generative AI is so prevalent nowadays, we often we confused that we tend to associate Gen AI is that AI that we are talking about. So it's not the case. So AI is a much broad context where Gen AI, if you are talking about set and subset perspective, so Gen AI is just one small subset of AI. Okay, all right. So it has many components as well. So we have AI for not non-generative applications as well. Okay. All right. So yeah. So if you are talking about set and subset, or the umbrella, or the child of the umbrella. So the of course the parent umbrella is the AI, the biggest field of study. So probably the smaller subset is the machine learning. All right, and inside the machine learning is the deep learning. All right, so normally the question arises: what is the difference between deep learning and machine learning? Because the name is quite similar, right? Yeah. So if you see deep learning models and machine learning models, okay, but of course, in the context of set and subset, deep learning is the subset of ML. But deep learning, it actually a subset of machine learning, yes, but it actually the backbone of deep learning is the neural network. Okay, while machine learning models based on other techniques, all right, but deep learning specifically is based on neural network or artificial neural network, we say it. All right, so that's why deep learning is also known as deep neural network. Okay, deep neural network, or deep or multi-layer neural network, multi-layer perceptron, and so on. Okay, and of course the smallest subset here is the generative AI that we have known nowadays. Okay. Okay, so the evolution of AI. So, all right, so some applications. Okay, some applications of the deep learning. All right. Of course, we nowadays is uh, uh, not uncommon to see this type of applications. So for face recognition, for example, okay, and then post estimation. The speaker just now, the Dr. Hazrat, is very active in medical images. So for example, cancer detection. Okay. And we have nowadays also generative video analytics. Okay. For example, we can do some deep fake. All right. Okay. And then of course we can also have other applications in, for example, restoring old photographies, for example. Okay. All right. So this is a timeline of the deep learning. Okay. All right. So let's see. So this timeline starts, for example, in 1940s up to today. All right. So for example, if you see this timeline, even in 1943, the artificial neuron has been proposed. Okay, so if you go a little bit in the future, so in 1957, okay, we have what we call as the most basic unit of the neural network, which we call it perceptron. Okay, was proposed in 1957. So this is the day Malaysia got its her independence. This is Independence Day in Malaysia, 1957. So even at that day, year, perceptron has been proposed. Okay, so and then of course the all the family of the perceptron. So Adeline, XOR, and then in 1986, okay, the day that I was born, okay, in 1986, technique to train neural network has been proposed, which we call it back propagation. Okay, all right, and then of course in 1998 we have what we call as convolutional neural networks, a very popular model nowadays. Okay, for the analysis or process of the images and videos. Okay, it is a very old model already. So it was proposed in 1998. It was proposed actually for the document analysis by Ian Laken. Okay, and then of course we have several, what we call as if you see here, they call it like dark ages of AI. So or some people call it winter of AI. So like we have some sparks of AI hypes. Okay, and then we will it will be followed by several years of our winter AI, or the dark age of AI, that where we don't have any more new things in AI. So for example, here the second dark age is here. Okay, and then starting 2012, okay, when AlexNet was proposed, now the hype of AI starts. So this one starts where people call it deep learning. So I think most probably this is the start of the age of deep learning. People start calling the deep neural network as deep learning. Okay, while before that that term is not very common. Okay, starting 2012, and then of course 2014 we have the first GANs, okay, the generative adversarial network. And then 2017 we have a very powerful network called transformers. And of course nowadays we have several families of the transformers have been proposed. Okay, and then of course AI is applied everywhere. Okay, whether let's say I'm my background is engineering. So even in engineering, we have multiple fields in engineering. So even in engineering, it cannot live without AI nowadays, right? So whether you are in the mechanical department, automotive department, or even you are in the chemical engineering, of course, AI will be at the core to this activities. Okay, so so are you familiar? Are you familiar with this figure? So this is the visualization of what we call as neural network. Okay, so just very quickly on this fundamental, because we don't want it to be too extensive on the fundamental. Okay, so this is what we call as neural network. Okay, so neural network consists of several layers. Okay, so if you see here, layer 1, layer 2, layer 3, layer 4. So in deep neural network nowadays, it can be hundreds of layers. Okay, hundred of layers. Okay, and at each layer, all right, so it consists of several, if you see here, we call it nodes or cells. Okay, some neuron. Okay, so you can call it neuron, nodes, or cell. Okay, so it has multiple neurons at each layer, right? So and this neuron is connected in this case is connected densely to the neurons, all neurons in the next layer. Okay, meaning that it give the information, okay, to the next layer, and then the next layer will give information to the next layer, right? So let's say our input is an image. Okay, and the task is classification task. So we will fit our image as input to this neural network. Okay, and then we will do the forward computation, or we call it feed forward. Okay, in the forward manner from left to right. Okay, and then up to the right side, which is the output. Okay, depending on our task. Okay, so if our task is classification, so the output needs to classify the input, whether it's dog, cat, person, or any objects. Okay. And then what the neural network will do is it will learn the this network. Okay, how it learns? Okay, how it learns is by if you see here the connections between the layers. Okay, so the connections between layer 1 and layer 2, for example, in this green color. Okay, so this connection, we call it in neural network, we call it weights. Okay, we call it weights. So sometimes we call it parameters. Okay, but it's more commonly known as weights. Okay, so these weights, of course, we will start by any random number. Okay, so when we say we learn or we train this model, what we want to actually do is we want to modify these weights. Okay, so we want to modify these weights such that when we feed the image as input, the output should give us the best prediction. Okay, so how do we know that we have the best prediction? By we calculating the error between our prediction and the correct value. Okay, what we call in neural network as loss. Okay, so let me use my pen here. So okay, so this is where we have the loss at the output. Okay, what is loss? Loss is just the error or the difference between our prediction. So let's say our prediction is y. Okay, we will calculate the difference between our prediction and our true value. Let's say our true value is t. Okay, so we want to make sure that our weights here, so let's say I call it this weight 1, weight 2, and weight 3. Okay, of course we have 4 here. All right, we want to make sure that these weights, this combination of weights, okay, when we input the image to this network, we want to make sure that the combination of these weights, W1, W2, W3, W4, will give us the lowest loss at the output. Okay, all right. So this is what we mean by training the neural network or learn the neural network. All right. So we train normally commonly used method to train is we saw just now is the gradient descent method. I won't go into details on that. Okay, but that method or algorithm is used to update this weights. Okay, all right. So that's so we have the forward computation that I I mentioned just now. Okay, so up until the loss. When we get the loss, okay, so let's say our first loss is 10, for example. Okay, in our first pass or first iteration is 10, right? So what we do next is we will bring back this loss to the left hand side. So we go backwards. We go backwards. Okay. What we call as back propagation. Okay, back propagation. And here is where we will update this weights based on the gradient. Okay, so I won't go into detail. So when it goes back to the input, okay, so we will finish one iteration, or in neural network we call it epoch. Okay, so epoch, epoch. Okay, so epoch 1 finish. Okay, then we will start the next iteration or next epoch 2. We will start again by doing the forward calculation. Okay, so we go again, forward calculation. Okay, with the updated weight, okay, with the updated weights, W1 updated, W2 updated, W3 updated, W4 updated, we get a new loss. So in the second epoch, we are expecting that we want to minimize this loss. Okay, so let's say in the first epoch we get loss of 10. We want to make sure that it is lower than 10. So for example, we get 9.5, for example. Okay, so when this loss is minimized, we say okay, now the network is learning to minimize the error. Okay, and then we will do this until we minimize this loss further, until we actually saturate that such that the loss cannot be minimized anymore. Okay, all right, so that's very very quickly on the just a simple background on neural networks, where this is the at the core of the any deep learning algorithms nowadays. Okay, whether you are talking about new algorithms such as transformers. Okay, people are using transformers nowadays, vision transformers. Even in vision transformer, we use the same techniques to train or to learn our model or neural network. Okay, so that's okay. So let's take some okay, discard. Okay, so let me see. Are you okay at this point? Okay, are you okay at this point? So I just want to, because in Kuala Lumpur, I'm not sure in India what was the time now, but in Malaysia we are already 9:30. So it's already at night. Okay, night time. But I'm still very much awake and enthusiastic. Okay, all right. So it looks like some of you give thumbs up, meaning that you don't have any problem as of now. Okay, all right. So let's continue. Okay, so let's continue on our discussion. So it's 7:04 p.m. in India. Oh, all right. Okay, 7:04 p.m. Okay, so the difference is like 2.5 hours, I suppose, right? Okay, 2.5 hours. Okay, not too big. Okay, good. All right. Okay, so now let's continue. Okay, so we talked just now on the timeline of deep learning. All right, timeline. Let me go back a little bit. This timeline, right? So we know that the for example, back propagation here has been proposed in 1986. CNN, which is at the heart of machine learning or deep learning nowadays, has been proposed in 1998. So for example, back propagation is already 39 years old. Okay, 39 years old. But the question is why only at this point? So if you see here, at this point in 2012, when AlexNet was proposed, this is where the deep learning, deep learning starts to take off, or start to. When I say take off, meaning that the performance of deep learning can surpass or outperform. You can outperform the human performance. Okay, and of course, AlexNet is the first deep neural network model, which is of course CNN, a convolutional neural network, that first time outperform human performance in the data set of ImageNet. Okay, which is a large scale image data set for the image classification. So only in 2012 we actually see the performance, the real world performance of this AlexNet. Otherwise, before 2012, we can only see CNN at the lab scale, only in research papers, and only in the working in the lab. All right. So this is some gap of how many years. We want to know why it's taking so long for the deep learning to actually flourish. Okay. So okay, why is AI taking off? Okay, so if you want to take the analogy of a rocket. Okay, take the analogy of rocket. Okay, so let's say the rocket has some components, right? So let's say the rocket has the engine and it has a fuel. So if we take this analogy and use this to describe deep learning, we can say that the algorithm is like the engine of the rocket, okay, which drive the rocket to take off, okay. But a rocket is nothing, without the fuel, okay, without the fuel. So of course you have the best engine in the world, but of course it cannot take off without proper fuel. Okay, so this is what happened. So only when the internet comes into picture, okay, I think if I'm still remember, okay, probably in the 1990s, okay, early 1990s, we have the internet. Of course, even at the beginning of the internet era, we cannot have lots of data, but starting probably 2010, okay, we have start to have the social media, okay, social media, and we have many platforms to actually have a very big collection of data, okay. So this is what we call as big data, okay. Why we got big data? Because of internet, okay. So of course without internet we cannot get this huge amount or the plethora of data, okay. So if the model is the engine, the what fuel the engine is the data that we have nowadays, okay. All right, the second thing, why only in 2012 deep learning has started to take off, because of this, okay, because of the what we call as computing power. So if you, I think you are already familiar with what we call as GPU, okay, graphical processing unit. So for those who play games, okay, like myself, okay, so we have a GPU. So before this, we use GPU for gaming, okay. It turns out that this LXNet team use GPU to actually train, used to train the algorithm. So because we know that the AI model or AI algorithms is a data hungry algorithms. Okay, so it needs lots of fuel to take off. All right, so the thing is using a CPU, the processing will be sequential, which is very slow. Right, so when we have the graphical processing unit GPU, so now several computation, okay, of the weights, okay, calculation can be computed in parallel, okay. So that's what makes that's what accelerates the training of the network, okay. So if you try to plot the performance versus the amount of data, so you will realize that deep learning will saturate the performance as the amount of data increase, okay. Unlike the all the algorithms such as for example SVM and random forest or other machine learning models that comes before deep learning, right? Okay, of course the computing power, right? The computing power. So even LSNet, if I'm not mistaken, was trained on two GPUs. Okay, GPU cluster. Okay, so you can see here even the LXNet have some 62 million parameters that you need to compute, right? Okay, so bigger models such as the VGG has some 138 millions. In today's deep learning world, this already considered small. Okay, it's already considered small models, because nowadays if you are talking about for example GPT models, okay, GPT models, or the transformer based models, okay, so we are talking about billions of parameters, okay. That was trained on cluster of GPU, for example 20 GPUs in one go, okay. All right. So this much of number of parameters needs a very high computing power. So this is where the GPU comes into picture. So that's why nowadays you see, the stock of Nvidia become very very high. Even for the AI based companies in Malaysia is flourishing nowadays, right? Okay, so now let's move on to some applications. Probably we talk about several applications of AI that we do in IUM or in our center. Okay, uh, as I told, our center focus our research on the applied research. So applied research meaning that I take the word of our professor just now, that uh, our faculty members or researchers need to embark on research, AI research that can solve the real issues. Okay, that can solve the real issues faced by the community, faced by the industries, the government. So we want to use those knowledge and resources to actually solve real things. Okay, instead of stuck at the lab scale level. Okay, so here I will show some examples of those what we have done, and some opportunity in the future. Okay, all right, some opportunities. So okay, nowadays we are talking about if you want to implement AI on real machines or real robots. Okay, so we are now nowadays we are talking about edge AI or embedded AI. All right, so where we are implementing AI on the resource constraint platform. Okay, so uh, we will be covering in one of our sessions. I'm not sure, probably day 3 or day 4. Okay, so this is one of the uh, hot things in today's industry. Okay, so yes, we can run AI, very big AI models on our GPUs, on our GPU clusters and our clouds. Okay, but how do we actually implement this for the real world things? Okay, that can run on site, that can has a constraint on energy resources, for example, or that is has the constraint on the connectivity. So how do we implement AI on those kind of conditions? So this is where we have the embedded AI as one of the solutions. Okay, so if you see nowadays AI in unmanned technologies, the adoption of AI, embedded AI for unmanned technologies has increased. For example, for drones. Okay, of course using edge computing. Okay, uh, why do we need this sort of edge AI computing, because of course we want to use it in the resource constrained conditions. Okay, at the same time we can reduce the latency, right? So if you are comparing the AI platform, edge platform, compared with the cloud-based system. Okay, so of course it has an advantage in terms of latency. Okay, improve performance. Okay, where we can actually have quick updates with the real data on site. Okay, lower bandwidth compared to the cloud system. Okay, enhance security, because we don't run it on internet or cloud, so we have less opportunity to be tapped. Okay, or fooled. Okay, of course increase reliability and cost saving as well. All right. Okay, so another opportunity on the AI, of course, nowadays we have bunch of open source libraries. Okay, so for example, the popular ones nowadays are PyTorch, for example. TensorFlow, Keras. I'm sure that some of you are familiar with these names. Okay, this actually provide the opportunities for all of us to actually start our journey on AI projects. Okay, without if you are talking about this, let's say for example before 2016 or 17. Okay, of course only those in the academic world can or in the very big company can have access on AI or deep learning. Why? Because we don't have this type of open source libraries. Okay, starting 2016, 2017 onwards. Okay, so we have these open source libraries that provide access to all people that can try on any AI models. Okay, for their own projects. Okay, the opportunity as well. We have this many libraries and platforms. So nowadays we can also run this cross-platform. Okay, so let's say we have PyTorch and Keras, right? So the models that have been trained on PyTorch, for example, can also be run on an environment of Keras. Okay, or other or TensorFlow or other uh, environment or other libraries. Okay, so this is actually very good features, because we have this is a big problem. If you say for example 5 years ago or 6-7 years ago. Okay, so nowadays it's quite easy to have your model to be trained on one platform and run it on another platform. Okay, and of course nowadays as well it's quite easy to start with deep learning. So we have lots of tutorials and courses on the internet. Okay, that everyone can access. So if you heard about GitHub. Okay, so even for researchers in AI and deep learning. So if you go to the research papers, normally most commonly all the papers will share the codes on their own GitHub, so we can actually read the paper and then we can directly implement their algorithm directly on our local machines. Okay, at the same time we have also the open platform education platform, for example the Udemy, Coursera, and so on, right? Of course, due to low cost hardware, which is inexpensive nowadays. All right, we can directly start with the deep learning. You can directly learn deep learning. So let's say you have only one laptop and with one webcam. So you can directly start with your journey in AI. So it's not difficult nowadays. All right. Next one, of course, we have nowadays we have emerging algorithms to solve many, otherwise difficult or complex tasks before. Okay, so for example, emerging algorithms include this reinforcement learning. Okay, normally used for the uh, applications of robotics. Okay, I'm from robotics, so reinforcement learning is widely used for the autonomous navigation of the robots, for example. Okay, and nowadays also we are talking about transformer-based models. Okay, that in many tasks outperform the conventional CNN or the convolutional neural networks. Okay, so also the emerging algorithms as well on the self-supervised models. Okay, so where using this model, um, you don't have to get the curated data set that is labeled anymore. Okay, so where we know that the annotations of data is not easy. Okay, so we have some emerging techniques or algorithms nowadays that focus on the self-supervised learning, so that without the annotations we can also get a plausible models to solve several tasks. Okay, so after this, I will start to talk about what projects or the research that we embark or develop in our center. So before that, let me check first on the participants. Okay, so is everyone okay right now? Is everyone fine? Still following? So hopefully, starting today and onwards, hopefully you should bring your cup of coffee. Okay, cup of coffee with you while you are following our sessions. Okay, so that hopefully can help you to follow our sessions closely. Because our sessions, as I told, uh, quite heavily hands-on. I know it's not easy to cater to like 200 participants. So normally we deliver workshops for uh, you know face-to-face workshops that we can actually, okay, so if someone has problem, we can actually solve their problem at that time. So we know it's not easy to deliver hands-on sessions for a big crowd like this program, but we will see. Okay, we'll try our best to find the best way to cater to the all participants' needs. Okay, so that we hope that starting with our program, it can be the starting point for you to go further after this. Okay. All right. Let me check in the chat box. Feedback. Okay. Very contentful. Okay. All right. All right. Oh, there's one question on application of edge computing. So yeah, we'll see after this in some of our projects in our center. Okay, where we use edge computing extensively in our projects. Okay, so okay, looks good. Looks good. Okay, so if you have any problem, yeah, you can of course ask in the chat box as well. Okay, let me continue. All right. Okay, so now I will start to talk about about the real world projects that we embark or develop in our center. Okay. Again, our center's name is Cute. Okay, there's a very easy name to call. Okay, Center for Unmanned Technologies. So therefore, you will see after this several projects on unmanned technologies. Okay, so it's applied AI projects on unmanned technologies. Okay, so the first one is we firstly we embark on what we call as ADAS system. Okay, so advanced driver assistance system that I think is nowadays is already common in modern vehicles. Okay, so that you will have ADAS system as one of the features in the car. Okay, so we actually developed this for the local company. Okay, so in Malaysia we have our national car industry. If you ever heard about we call it Proton, Geely and Proton. Okay, Proton Geely. Okay, so and Prodoa. So we have these two biggest name in Malaysia. So what we did before this one, we embarked this starting in I think 2018. Okay, we did the ADAS system for their car. Okay, so nowadays is like a commonplace in their latest car models. Okay. Of course, this ADAS system includes as well the forward collision warning system, right? If you have, if you are on certain range to the following car, okay, so the system should give some alarm, okay. All right, and we also embark on the what we call as around view monitoring. Okay, this one is also commonplace nowadays. Okay, so some cars use other terms. For example, if I'm not mistaken, Toyota term it as PVM, panoramic view monitoring. I think others use surround view monitoring. So those are actually denote the same thing. Okay, this is used for the parking assistance for the car. Okay, of course using cameras surrounding the car. Normally, actually, at least we have 4 cameras around the car. Okay, in our center as well, we are active on 3D vision. Okay, on 3D vision. So, for example, 3D face recognition. Okay, so one of our projects also to to make the man toll system. So I'm not very sure what toll system is there in India, but in Malaysia we have this type of toll system where in each toll plaza we have the attendant. Okay, that will manually if you see here, let me change to the pointer. Okay, so if you see these buttons, the some keypad here. Okay, the blue, yellow, red, green, and white buttons. Okay, so those are actually the 5 classes of vehicles in used as a standard in Malaysia. Okay, so for example, class 1 is for the sedan car. Okay, class 2 for the buses, class 3 for the truck with 1 axle, and so on. Okay, so I'm not very sure the exact classification, but those are the classification used in Malaysia. So what this attendant will do is, it will, when the car arrive, it will choose which class the car belongs to. Right. So for example, this car, okay, she will press the blue button, for example. Okay, and then the pricing will appear. Okay, so you need to pay this much, and of course the driver will need to tap or use the RFID tag and so on. Okay. So what we did is we changed this manual system to an unmanned tool system. What we do is we just what we do is we actually replace this system, this manual system, to a very low cost system. Okay, so we just place a one camera here, and we do the object detection using AI model. Okay, that object detection we will cover in one of our sessions. Okay. This is an example of the output which runs on the embedded platform. Okay, on the edge AI. If I'm mistaken, this run on one of the Jetson boards from NVIDIA. Right. So for example, when the car arrive, we will detect the number of wheels, because the type of vehicles, the classification in Malaysia heavily relies on the number of wheels. So we need to detect the wheels, and then we need to detect the car and to classify. So when we classify, we can automatically give the pricing to the customer or the user. Okay. Of course, our end goal is to have the multi-lane free flow traffic system, like the one that we already there in several European countries, as well as countries such as Singapore. All right. Okay, so some examples of this unmanned toll system. Okay, so detect the car, detect the trucks. Okay, the big trucks, the bus, and of course the class of taxi. Okay, because normally class of taxi or the emergency vehicles, such as ambulance or police car, we shouldn't take any pay from them, right? So because they are emergency cars, so we need to detect that and should let them go without paying any fees. Okay. All right. So our system, of course, detects or have the high accuracy even at night time. Okay. We only use a very low cost camera, color camera, RGB camera. Okay, but as you can see, even at night time, the accuracy is very high. Okay, some more examples. Okay. Of course, this project is in a collaboration with our industry partner. Okay, the Deloitte and Coutts. Okay, this is at the same time. This is for the ALPR. Okay, the automated license plate recognition for outdoor applications. This one is also for the toll system. We detect. We know the user from the registration number. Okay, and then based on that, we give a more precise fees or the payment that they should make. Okay. Okay, so one of the projects as well is this, what we call as Medibot, okay, or medical robots. So this is, we appear in, of course, one of the news in Malaysia. Okay, this one we proposed during COVID, of course, and autonomous robots that enables the doctor to have, the telepresence applications, with the patients from far, okay, or even from their home. Okay, these are medical robots. So one of the application of the Edge AI. Okay. All right, so the latest version of this medical robot that has been in use in one of the government hospitals in Malaysia. Okay, one of the states. Okay. This is our queen at the top or bottom left. Okay. All right. So okay, we also embark on projects with oil and gas companies. Okay. For example, one project here is to use a surface vessel or simply a boat to do the mapping of the underground mapping. Okay. So for any applications, for geology, for hydrography. Okay. So what people will do conventionally is to hire an expert, uh, a mapper or surveyor, and with the manual boat, right? So you will go to the very big space and try to map. Okay, what we did is we replaced those with an autonomous or unmanned space vessel, although it's not fully autonomous, semi-autonomous. Okay, but we make it unmanned. Okay, even without the expert surveyor, we can actually do this mapping very efficiently. Okay, using our unmanned surface vessel. Of course, this is also one of the applications of HAI. Okay, where where we do the object detection, the obstacle avoidance, all on board on the board of the surface vessel as well. Okay. All right. So some more examples. Okay. So all right. So for this surface vessel as well, we actually developed what we call our own edge device, or our edge controller. Okay, that we call it as CXSense. So already in the commercialization phase. Okay, so this is the AI box that we have. We call it CXSense. Okay. Already passed the several tests for the commercialization. Okay, so it's powered by the NVIDIA Jetson board. Okay, that enables us to run any deep learning model or AI models on board. Okay, on the edge, as the edge computing of the system. Okay, what makes this different from those that are already in the market is our system here is actually modular in the sense that we can just plug and play any payload that we want. So let's say for the task of mapping in the hydrography applications. Okay, so we have several payloads. For example, we have several sensors. Okay, radar sensors, right? LiDAR. Okay, so before this, it's very difficult to have the interface between those sensors and our edge computing. So using this, our developed controller, we can just plug and play to various payload, different sensors and different actuators. Okay, different motors and so on. Okay. All right, so we also have this application of vision inspection system. Okay, so normally when you have the manufacturing line, okay, so this is for the pin defect inspection. Okay, so if you see here, this is the side mirror of a car. All right, where after the assembly, okay, and after the painting of the parts, okay, we want to do the quality check, okay, or quality assurance. So what in the industry, even in Malaysia, do is they just use some expert evaluator to manually inspect the quality of the paint. So of course, this is subjective from one expert to the other, and of course, this is a tiring job that you need to have lots of human expert to do this quality check. Right. So instead of that, we replace those to an automatic system. Okay. We use an robotic arm. Okay, with some jig that can hold the parts. Okay, and what we do is we use the object detection. Okay, the AI models to actually do the inspection for us. Okay, so for example, we can detect this tiny defects. For example, what is this? Dust, for example, dust and string. So there are multiple types of defect in the painting. Okay, for example, the fingerprint. Okay, dust, what else? Pinch and so on. Okay, so those are very tiny. Okay, not easy to be inspected manually by using our naked eye. So using this AI-based system, we can actually increase not only the accuracy but also the efficiency of the overall quality inspection system. Okay. All right. So some examples. Of course, this is the some integration of multiple methods, not only the AI model. So some methods of the machine vision that we use, what we call as deflectometry. So of course we won't cover that in our course. Okay, some video. Right. Okay. Yeah. So we also appear multiple times in local media. Okay. In the news. Also, we presented our work with our prime minister, if you know him. Okay. A good friend of your prime minister. Okay. All right. Okay. So now well, we are towards the end of my presentation. So some challenges of the AI for the unmanned technologies. Okay. All right. So it can be expensive. Okay, for real application. So if you consider, for example, this autonomous system, autonomous car. Right. So of course, autonomous car, we will be needing the sensors. Okay, such as lidar. Okay, just one lidar. Right. So lidar is known to be a very expensive sensors. Okay, so I'm not sure in India, but in Malaysia, it costs something like 60K, 60,000 ringgit. If you convert that to US dollar, probably 15,000 for one, right? So normally for self-driving car, of course, you will need at least three of them. Of course, if you want the system to be more accurate, you need a lot more lidar to get a denser point cloud. Okay, so this is a challenge for the real application of AI. So it can be expensive. This is also a challenge. In to this industry to get the to not to get the AI talents, but to preserve the AI talents because AI talents nowadays are on a high demand. Okay, so it's not easy to maintain your AI talents in your company or in your organization. Okay, so this is also a challenge. Also, a challenge is data collection and annotation. So we know that for real applications, you will need to do lots of annotation, but the annotation is known to be very expensive. Okay, not only expensive in terms of the cost that we need to hire some annotators, right? Not only that, yes, it is expensive to hire those annotators, but it's also expensive in terms of time taken to come up with the very good data set. Okay, it is itself in itself is a expensive activity. Okay. I told you that open access, open source information is good. It's an opportunity in AI, but it can also be a challenge as well. Okay, for the this generation, because too much information is also a challenge. Okay, so you tend to be lost in this forest of information. So that's why yeah, instead of self-learn, of course you can self-learn those that we learn, especially in our course, but you will also need some structured way of learning. All right, so that you won't lost into this forest of information. Okay, and you don't know where to go. Okay, so these are the topics that we will be covering in our 6-day session. Okay, so for example, we will start with a very basic in deep learning, which Python. Okay, the programming language itself. After this, okay, so why Python? Because Python is the programming of today's AI system. Okay, so even like 2 or 3 years ago, people are talking about some new programming language or syntax will be replacing Python soon. But even in 2025, we can see that Python is still the most prevalent language to run the deep learning. Okay, so that's why we will be starting our course on Python. Okay, so that everyone is on the same page. Okay, and then we will start with the OpenCV. Okay, tomorrow. This is one of the most important open source library of computer vision. So CV is the computer vision. Okay, so and then the next session we will introduce one of the not one so nowadays the most popular libraries of deep learning, the go-to library nowadays. I think if you open any research papers nowadays, I can say something like 90% will use PyTorch. Okay, PyTorch. Okay, so we'll introduce PyTorch in the session 4. So next we will do some activities of the using PyTorch as well. For example, we will do the task for learning. We will be introducing the embedded AI. Okay, and then next we will cover also the object detection. Okay, this one using several libraries. Okay, and some use cases. Okay, we will do the object detection for the custom objects. Okay, our custom data sets. This one, the title here say for aerial drones. For probably we can make it open. Okay, for several applications. Okay, and then we will also be covering the video segmentation. Okay, instance segmentation and image segmentation and so on. And we will see some practical examples. Okay, so next we will see some practical projects of using the object detection. So for example, for the trackings of objects and counting of objects. And then introduction to ML ops. So ML ops is the the techniques used. ML ops stands for machine learning operations. So normally for the real production in industry, we will be using ML ops so that we can run and update the models in okay with the new data that's coming in, okay, from the video stream. Okay, and then we'll conclude with some session with faculty member. Okay. Okay, so these are the libraries that we will be using. So Anaconda, that is comes with the Python, built in Python, and then probably we will be using this Python, what we call as IDE. Okay, the platform to run the Python. Okay, so probably in this course there are several IDEs. So probably the easiest to start with is the what we call as Visual Studio. Okay, and then we will also be running the OpenCV and PyTorch. Okay, so hopefully when you go back after today's session, hopefully you can have this Anaconda and Visual Studio run on your laptop if you want to run. Okay, if you want to follow closely on our sessions. Okay, I recommend you to have this installed on your machines. So okay, and Anaconda and Visual Studio. Okay, so yeah, we will be learning on these things. OpenCV will be covering the image classification task with PyTorch. So we start with neural network, convolutional neural networks, transfer learning, and so on. We will do the object detection with what we call as YOLO. Okay, and custom training on custom datasets. Okay, and we will be also covering on the what we call as auto labeling, yeah, using the foundation model. Okay, instance segmentation, as I told just now. Okay, and last but not least, we will be covering on the new and emerging techniques in industry. Okay, we use the what we call as foundation models to increase the efficiency of the annotations, and also for the training of the deep learning models. Okay. All right. So that's pretty much what I want to cover in my first session. Okay. So let's go back to our Google Meet. Okay. Google Meet. Google Meet. All right. Okay. How is it going? Can you still follow? So hopefully you are now clear what you are expecting in our sessions after this. If you have any problem, you can raise your concerns or problem or questions at any time. I think you have the WhatsApp group, right? WhatsApp group. Also, we have some resource person, or you can talk to the coordinator, and the coordinator can relay the message to us. Okay. All right. So now probably we have the PowerPoint, please? Yeah, of course. Probably I can share to the coordinator afterwards. But just a head up, my PowerPoint here that I present today is quite big because it has several video files. Let's say I have also converted to PDF before, but still the size is quite big. I'm not very sure if is suitable for, but I just say I just share so that everyone can have the slide lah. Okay, no problem. Okay, so let's see if you have any question in the chat box. All right. Wow, no, the chat has
I request Dr. Hasan sir to
yes,
stop sharing the presentation, sir, so that
sure.
your screen can be full.
Sure. Now I okay. I have stopped my presentation. Okay. So now let's go to the Q&A.
Thank you, sir.
If any. So let's see. Okay. Can we run deep learning algorithms with CPU when the data set is small? Yeah, definitely. You can run the CPU. Not if the data is small. Do you mean to train the deep learning algorithms with CPU? Yeah, so there are two things. So if you with what you mean is train the deep learning algorithms on CPU, it is highly not recommended. Okay, highly not recommended, because even on small data set, it will take forever. To train. So at least train on the cloud platform. If the data set is small, probably we can use open source platform such as Google Colab. Probably we will be covering those as well. in our sessions. Google Colab. We have also the Kaggle Cloud. Okay, Kaggle Cloud. Also we have several others. For example, what's the name? Paperspace Gradient. Paperspace Gradient also have some free free tier of GPU that you can use on the cloud. Okay, but what you mean? What if you mean is to run in terms of inference? Of course, using CPU, you can. If the model is not big, if the model is small, and for example, like mobile net, which is quite small, but of course, at the expense of lower accuracy. Okay, so you can run on CPU with small model, but of course, small model cannot have a very high accuracy. So you need to have this trade-off when you run the deep learning models. Okay, accuracy versus runtime. Which one do you want to go? Okay, depends on your applications. Why current researcher choosing deep learning? Of course, because deep learning is a go-to method for research in many fields because it can solve many tasks. Simply, okay. So, for example, if the task or the problem is classification task, detection task, segmentation, or even to generate a new data like Dr. Hazrat Ali mentioned just now. Let's say in medical applications, we don't have many data. Okay, the data is confidential, for example. Okay, it's not easy to get. Also, the same problem we had in our hospitals in Malaysia. So they cannot share because the PDPA, the Personal Protection Act, some Data Protection Act. They cannot simply share the medical data. So what the researcher do, they generate new data, synthetic data for to train deep learning models. Okay, so why choose deep learning? Because it is very powerful and can solve many tasks. Okay, but of course you need to understand what task it can solve. Of course, it cannot solve all the problems in the world. Okay, so you need to really understand what on which specific task the deep learning can be very useful. Okay. Which algorithm for video analysis which give best results? This is a very subjective question. Okay, so depending on your application again. Okay, so if your application needs real-time performance, of course you cannot run a very big models, right? So if your best is run on real time, of course you need to sacrifice the accuracy and vice versa. Okay. Raspberry is suitable for deep learning. I've already mentioned this. PyTorch is the most popular nowadays. Okay, and most widely used. Even big giant companies use this, such as Facebook, Google, and so on. Okay, so
Thank you, sir.
yeah.
So I would like to inform the participants that Dr. Hasan will be joining us in the further session in few days, and we
Okay,
can
sure.
answer a few more questions, and in deep we can dive there. So
Sure.
our next resource person is also online, and he is also waiting. Sorry to
Okay.
interrupt you, sir.
Sure. Thank you everyone for participating, and see you again in the future.
On behalf of everyone present, we extend our heartfelt gratitude to Dr. Hasan for delivering such a beautiful and informative session on the introduction to deep learning. Your ability to simplify complex concepts and showcase real-time application of deep learning has truly been enlightening and inspiring. We can see in the chat that many of the participants have given thumbs up and all those emojis. It's flooding. Okay, and there are so many claps are also flooding. It shows that your session has been very informative. Your session has not only deepened our understanding of this fascinating field but also motivated us to explore its vast potential. We deeply appreciate the time and effort you have dedicated to share your knowledge with us. Thank you once again, sir, for your remarkable and impactful session. Okay, now I would
Thank
like
you.
Dr. Zakir, sir, to introduce our next guest.